Hi everyone, welcome back to my channel. Today we are diving into one of the most important problems in two-pointer pattern, containing that is container with most water problem. So this is classic lead code medium problem, and if you understand this and the logic behind it, then many pointer based optimization problem will be super easy for you to solve. So let's begin. So this is the problem statement. So here simply we have one container and heights of that are given into an array to us, and we have to just tell the maximum area, like which heights we can keep most wider so that we can store maximum water in it. So it's simple, but so let's pause and think what can be the logic applied to this problem. So we'll discuss in next slides. Yes, so remember the container cannot be slanted, so the area completely depends on the width and between the two lines and the shorter among them. Because let's say if one height is bigger and the other end height will be smaller, so water can be only up to the mark with smaller line, right? Not with the bigger line. So that it is mentioning. So let's see the examples. So this is the height given heights in the array form. So from this maximum area can be the 49. So let's understand visually from here. So as I said that these are heights given. So 1, 8, 2, 6. Similarly we have drawn all the lines. So what we have to keep the area maximum area. So maximum width is we can see this, right? And the maximum length which we can see is 8, and at maximum width the maximum length is 7, so this will be the answer that elements are 8. So 8, and first we have first max length will be 1 uh, at one place, so from 8 will minus 1, so we get 7, and the maximum height we are using that is 7, so the area will be 49. 7 into 7, 49. So this is how we have to calculate the area. So here are examples and constraints. Example 1 gives us output 49. Example 2 has two lines, height 1 and 1. So width is 1 and height is 1. So area is also 1. So constraints is also important, that n can go up to 1 lakh. So we definitely need something faster than of n square, right? So let's see the brute force approach for this. It's simply that we have to find all the pairs of the lines that and find the area for all lines. That means we have to find distance between this and this line, this and this line, this and this, and then find the maximum area out of it. But that can be like really to solve. That will to take too much time, like n square of time. So we cannot go with that approach. But yeah, we can see like how that basic approach can be done. So see, we have similar like previous video we have seen two pointer, it's the same solution, like we need to apply two loops and then we'll calculate width, we'll calculate height, like because from two lines we have to calculate the minimum height, like we already saw, right? So this we have picked. So in this way we in code also we need to pick minimum height and then calculate the area and update the maximum area out of it. So this is the brute force approach. So second approach, which is two pointer approach, that is optimal one. So here the idea is that we'll move, we have two pointers, right? So but we have to move the shorter one. Like let's see through diagram only. So let's see, if we have let's see we have first pointer here. So when we find it shorter with this pointer end pointer, so we will move this pointer instead of this, because our area we have to calculate the maximum. So with shorter pointer, obviously that we cannot get the maximum area. So let's say if we have moved this, so we will never be able to find the maximum area. So with shorter point, if we find shorter one, then we'll move the line. So if this point, if this line was here, so we move the right pointer, not the left. So this is the idea. So, moving the shorter pointer might give us a better area. Moving the taller line can only decrease the area, right? We have checked through diagram. This guarantee we don't miss the optimal solution. So, if we move the pointer with the shorter height, we might find a taller line that compensates for the reduced width. So, this is how we'll implement the solution for this. So, this is the solution. So we'll simply take two pointers. One will start from the beginning, one will at the end. And max area will set at 0. So we'll calculate area by just width will be obviously right pointer minus left. Then we'll find this x-axis width, right? So that will be the width, and the minimum height we'll find out of both the pointers height. And then we'll just update the maximum area like from the previous area which was 0 and the current area, so that each time if the area will be calculated we'll pick that maximum one, not lose the optimal solution. So, and how to move the pointer? Simply we have discussed that whenever we find the shorter height pointer, then we're going to update, increase that pointer. So, look in this, when we are getting left pointer as shorter, then we are moving left pointer. And when we are in else part, when we are getting this right pointer as the bigger one, oh, as the shorter one, then we will be moving this pointer. So this is how we'll move the pointers, and until we find the solution, we have to repeat this. So I hope from this we are able to get the solution. So now let's implement this solution. So let's move step by step. We'll first create two pointers, that is left, which will start from initial, and the right, which will start from the end, that means length, heights, height dot length. Okay, so then we'll have to create max area. So we'll create max area as 0. Then we'll start our loop, which will be left will be less than right. When two pointers meet, then we'll have to break the loop, right? So now we have to first calculate the width. What will be width? Right pointer minus left pointer will have the width now. So now we have to calculate the max area, right? Okay, we have already the variable max AR. So max math dot max will use max area will be max area we already have, and the max area that we're going to calculate. So let's calculate that first. Okay, so max area will be the area, okay, sorry, the width multiplied by the minimum height, right? Start min, and the height left and height of right. So this is our area, and we have to take the maximum area. So from this area and the previously set area that we have. So simply we, instead of this, we can write this as directly here, right? So that will be the max area. Okay. So now we have calculated. So now we have to move the pointers. So we'll move pointer by checking the condition. If height of left is less than height of right, then we have to increment the left pointer because left is less. As we see, when this is less, we are moving to the next pointer, so we'll move to the next pointer, and else we will just increment decrement the right pointer because it is already at the end. So we have decrement the right pointer. We'll write equal to condition. So because when this 8 and 8 will be equal, right? When these both will be equal, so in that case we don't have anything. Like the loop will be infinite. So we have to make this condition as well. So yeah, we have now calculated our maximum area. So we're gonna return outside the loop. Yeah. So now let's try to run this. Okay, we got error. Let's see. Okay, so we get length area out of bounds. So yeah, I guess we have, yeah. So length is -1 because length returns the overall positions and index works as -1. So now let's retry. Yes, so it worked, and so this is the solution. So now why we have used shorter pointer. So let's see current says current state. So when we have moved the shorter pointer, we have uh, increase the area, right? Let's see here we are pointing to the 7 and 3. So in this case our area will be like 15 and we are moving 3 to 4. Then we because this was shorter, so we moved forward. So width is decreased only by 1, but the area is increased in the multiplication. So we got one number better. So this is better approach. So let's say if we have decreased through this uh, right pointer instead of checking that left because that was smaller, we have we decreased the max pointer. So in that case, we are getting smaller results. So we are getting even worse results, so that's why we are moving with left pointer. So similarly in these situations we are working like this according to the scenarios. So this is step by step how when we move the pointers, then that uh, lead code scenario example. So when we are at the first and the right pointer is at 7, then we'll pick the height from 1 and 7, that will be 1, right? And the width will be 8 because total length is 8. So that's why the area is become 7. So and we will move the the area has become 8 as 8 into 1 is 8 and max area 8 because the max area was initially at 0, so max area will be 8. So height of 7 and height of right will be 7, height of left is 1. So obviously 7 is smaller, 7 is greater than 1. So we'll move the left pointer because this is smaller. This height is smaller, we have moved left. So we have now moved to 8. So similarly, now we'll again check. Then now we have this one is smaller. So we will move back. But since we have got our maximum area here only, so we'll calculate any of the areas. So we'll be at max area because we are comparing the areas. So this is how our solution is working. So now how to use two pointer pattern is useful. So greedy decision makings. At each step we have picked our best choice. Like with maximum area we are picking at each step. And optimal time complexity, we have reduced our time complexity here. Constant space, we haven't used extra space here also. Intuitive and elegant, the solution is easy to understand and implement. The logic is always move the shorter pointer is intuitive. So Now approach comparison. It is better than brute force one obviously, and space complexity is same, and it is obviously brute force is slower and this one is good and pretty faster. S- So when to use this this solution for such type of problem? When you have optimization problems like finding maximum or minimum of something, area and volume calculations like this problem, and the problems where moving one pointer eliminates possibilities, when you can prove a greedy choice is safe, and problems with constraints that make brute force too slow. It is not ideal for the problems where you are need to track all possibilities, when greedy choice cannot be proven safe, problems requiring backtracking. It's related problem. You can have a look and you can try by your own. This trapping rainwater to some, and lead code 42167 we have already covered. So in next videos we will be covering more problems or and new patterns. So you can try these problems by your own. These are similar ones. So three problems I have already covered. This one and one more I have covered today. We'll make one more video on this threesome in next video. So rest of them you can try by your own and practice that. So yeah, that's it for today's video. So thank you and happy coding and happy learning. If you find this video useful, then please don't forget to like, share and subscribe. Thank you. Bye.